Thank you. Okay, so I am Daureen Nesdill. I am the Research Data Management Librarian on campus, and yep, I'm still working from home. So if you need to contact me, there's my email. And my email I'm pretty sure is still on my the handout that you were provided with. Okay, so today I'm going to give a little background on why everybody has jumped on this data management bandwagon and where it came from. And then I'm going to talk about, so what is data? And then we will work our way into how to manage your data. Yes. Okay. So it just didn't start in the past couple of years. It actually started back in 1899 with the International Association of Academies. And this obviously is the Western world, not the Eastern world. So back then, the different associations, the different academies, and these are basically science academies, got together and formed that International Association of Academies. What was interesting to me was finally the people in social science and the people in science and engineering realized that they had the same goals, they had the same issues that need to be addressed. So in 2018, they merged their two groups to form the International Science Council. And under the International Science Council is CODATA, the Committee on Data. This group is responsible for teaching data management and sharing to researchers, students, governments worldwide. They also held conferences and they have developed working groups to address some of the problems with standardizing data and sharing data. In addition to that, UNESCO came out in November 2021 with their recommendations on open science. They want data shared. For data to be shared, it's got to be standardized. So the goal of open science movement is to make research and its outputs freely available and accessible for everyone worldwide in order to increase scientific collaborations and the sharing of information for the benefits of science and society. And we saw an example of open science during COVID. If you were monitoring what science was going on, what research was going on during COVID, you saw an example of this, but it needs to be improved. Needs to be improved. And back in 2011, a group of computer scientists, publishers, and scientists met to develop the FAIR standard. That is, for research to be truly open and shareable, they must be findable, accessible, interoperable, and reusable. And that's basically what a lot of people are working towards at this point in time. So a little bit about standards. You go back in time to Ford's original Model T. He developed and produced the Model Ts in one factory. So to put all the components of the Model T together, he had to develop standards so all the little components would fit and the car would run. Today, all the components of a car are built in different factories and assembled in a Ford factory. So those standards are even more important. This is the same thing with data. Data is created by researchers all over the world. How we share that, we can only share it if we standardize some of the procedures. Globally, a number of nations have mandates that their data must be publicly available. In the US, this started with the Obama administration. These mandates refer to government agencies and in some cases, the university research the government agencies fund. This is a map and a website. It was developed by the United States to catalog all the available government data in the world. So in addition to the 96 US federal, state, county, and city portals, it includes 218 portals from international countries and regions. And yes, the state of Utah does have a portal. So back in the United States, with regard to sharing data, it actually started with an amendment to the Freedom of Information Act. And I think that was in the 90s that it was amended. And what it said that if your research is funded by a federal agency, you must share that data and information about that data with anybody who asks for it. You must save the information and the data for at least 3 years after the closeout of the research. And if somebody asks for it, you need to give it to them. So in 2013, the White House Office of Science and Technology Policy, the OSTP, sent out a memorandum, and this is basically just referred to as the 2013 memorandum. And what this was to let all the agencies in the federal government know they need to sit down and put together a plan on how they were going to collect their data and share their data. There's a lot of research going on in agencies, and all that data needs to be organized appropriately so it can be shared. In addition to that, between 2000 and 2015, federal granting agencies started requiring data management plans. And this included the sharing of research outputs. And that's what I've been dealing with on this campus since 2003. What's helping me out at this point is that journals are now requiring that the data related to the papers that are submitted for review must have a link to the data. So the data must be actually now in a repository so everybody has access to it. And journals are actually rejecting papers if the data isn't available. And this isn't all journals, but that list is growing. So over a researcher's career, it can get very messy if a plan has not been developed to organize the research. Today, we see much of the research is conducted in collaboration with other researchers, which adds to this complexity. And some researchers are still struggling with a hybrid situation, whereas some of the components of the research are in print and some are electronic. Effective management of the research will improve the efficiency and save you time. You'll be able to find your data, and it avoids losing data to a catastrophe. And that actually has happened on campus. You will not have to remember what you did last month. And the other thing is, it's going to cost money to repeat that research. At this point in time, if you are going for a grant in Europe, you will have to conduct a search to find out if that data already exists before you can submit your grant. It's not happening in the United States yet. So data, what is data? The official definition of data is in the Office of Management and Budget Circular. That's under the White House. And that dictates all what our VPR office must follow when it comes to research. And the definition is a recorded factual material commonly accepted in the research community as necessary to validate research findings. It's vague enough to include all types of research. And the data, people think data, a lot of people think data is just something in a spreadsheet. No, not anymore. Not anymore, not these days. Those beautiful images that NASA provides us, they actually start out as zeros and ones and zeros and ones. And those zeros and ones are put through algorithms, and that's what creates the image that you see. A lot of research is now being done on text analysis, and even in the sciences, people are doing some text analysis. And you see the map on the right-hand side, lower right-hand side. Maps are a big thing in research now. We use geographical information systems, or GIS, to create digital versions of maps. And that means that we can layer data on that map and do a lot of data analysis. And then there are the audio visual data. You see there an interview. So you'll have an audio visual there. There is actually a researcher on campus who's taking pictures of snowflakes up at Alta and on a place in Alaska. And so he has hundreds and thousands of pictures of snowflakes. So data can be anything, can come from anything. And there's also this thing called legacy data, and which can be useful. So I've been working with a biologist who has 50 years of data that she's been collecting on the biology of a population of southern right whales, and they calve off the coast of Argentina. She has 84,000 slides. These are analog slides. There wasn't any digital slides back in the 70s. So everything she has, all the data she has from back then is analog. We have data sheets that she has a room full of data sheets. We have maps that we've been able to digitize with GIS. So all of that has to be digitized, and we're creating a portal so everybody has access to this data. And why this data is important is because this species of whale has become the canary in the mine for the health of the Southern Ocean. So environmentalists want this data. But planning the research, what I keep telling faculty is planning the research is not only about answering life's big question. You have to plan ahead and make sure you have all the resources you need to conduct the research. And since research is dynamic and not static, it should be evaluated regularly, and everyone involved in the project should know the plan. Now, your research advisor may have already established the project that you're working on, and I'm assuming most of you have already started this project, but he or she should be sharing this management plan with you. And since the granting agencies have decided that everybody must submit a data management plan with their grant, they've developed basic questions that need to be addressed in that data management plan. And basically, hey, so what is this data you're collecting? You know, what's the file format? What's the maximum file size? And how much data are you going to be collected? And you really need to know this because you have to store it someplace. And where on campus and in what system are you going to store it in? And how much security do you need to store it? So it's just something that's basically need to do any research. The other thing is who has access to this data. Big project, you'll have data that's collected. Some of it, everybody should have access to it. Some, not only certain people should have access to it. You have to set up a system who has access to what data and what security or confidentiality restrictions are there with the different data. And then obviously we all want to share the data. So sharing the data is archiving the data. Where are you going to archive the data and all the related documentation after the completion of the research? And also, how much is all this going to cost? Because you can include that cost in the grant proposal. I also tell researchers at this point, figure out what journal you are going to be publishing in and go find out what the requirements are of the journal, because that's going to lead you to what repository you're going to share your data in. Okay, are there any questions? Oh, there's one chat. Is that your URL, the chat?
Yeah, it's just the link to the evaluation. We don't have any questions yet.
Okay, so I'll continue. And all the documentation for research, you may have not thought about this before, but yeah, I've thought about it a few times. It's a lot of paperwork. It's definitely a lot of paperwork. Obviously, it's the grant proposals and everything related to that, any federal, state policies. But there's a standard operating procedures, or SOPs, and sometimes they're called protocols. Protocols are the procedure you use to conduct the actual research. SOPs are usually worried about the safety. And if you're working with chemicals, there's plenty of safety SOPs for you to follow. At this point in time, you can't just conduct research with XYZ instrument or even a chemical. You have to know what the name of the instrument, who put it together, what version of that instrument, or the lot number of the chemical, because it may affect the research if you change instruments, software, or supplies. That's one of the reasons why they're forcing people to record all this information. Social media is now, social media communications is now an important part of research, so that also must be kept, and correspondence, etc. Okay, and a little aside, just in case anybody is working with images, and especially if it's eventually going to be in a publication, some publishers will, if you alter the image, they will immediately reject your paper. So you need to be working with your advisor on what you can and cannot do with these images. You need to document all the changes you've made with an image and keep the original one, because people will go back and look at the original and the one you altered and see if you can interpret it the same way. To help people manage their data, you need to document it. And in social science, they've developed code books. In the sciences and the engineering, they developed lab or project diaries. And in computer science, they call it an experiment definition. No matter what it is, it's everything you need to know for anybody to conduct that research for that project. The glossary is obviously definitely important. when working on that whale project, I was actually the intermediary between the biologists and the IT people. And the IT people were describing what they were going to do and the taxonomy, and the biology people were like, what do you mean taxonomy? And so I had to explain that the word taxonomy actually originated in biology. It's how we describe the relationships among the animals, plants, fungi, etc. as an organ. And the IT people, they started using the word taxonomy at the beginning of the internet, because originally they were organizing information on the internet the same way the biologists were organizing animals and plants in their taxonomy. So the taxonomy means the same thing, organization of stuff, but it was used two different ways. So that's one of the reasons why I focus on glossary and on communication, because that's the biggest problem in research, is communication and the use of different words meaning the same thing, or the same word meaning different things. So the reason for a code book or a lab or project diary is when a new person enters the lab, they should be able to start working just by following the information in that book. Biggest object I have with students and sometimes faculty is, how are you going to organize all your folders and files? First of all, put together a README file. README file is just a file that describes your procedures, how you named your folders and files, and how you organize your folders and files. So this way, if you go on vacation and come back a month later, you can't remember anything, you just read the README file and you know what you did. So naming files and folders, it should not look like this. And I know among the students, you do see a lot of this type of naming. My rule of thumb is, if you cannot tell what's in the file from reading the file name, then you need to improve the way you name your files. And in research, you use a lot of different IT systems. And that's the reason why these best practices were organized. You need to really limit the length of the file name and the folder name. Most systems are okay with if you have 25 characters. If it's greater than that, you never know whether the system is going to bog down and you won't be able to get to your files. And if you have a good file naming procedure, you won't need more than 25 characters. Also, only use letters, numbers, and underscore and dashes, because those special characters are used to mean something in different research settings. You have to worry about that. And if you look at a URL, you will see that people will add uppercase letters so it's easy to read what's in the URL. That's for humans to be able to read. That's not for computers to be able to read, because those uppercase, they don't mean a thing to the computer. So you also need to have a strategy for version control, and please don't overwrite those extensions. In the handout, there is a link to a LibGuide, and a lot more information about file naming practices are in that library guide. And I just want to make sure everybody understands that in this world, in this computerized world, we do have the ISO standard that dictates that computers will read dates, first the year, 4 digits, and the month and the day. And that's the way people should be writing the dates at this point in time. I know I've been doing it for a while, and I was at a doctor's appointment and they wanted me to write the date on the application, and I followed the ISO standard, and the person who took my information said, I don't know what you put here, but we want the date. I had to explain to her it was the date. So not everybody knows about it, but yeah, let's get people educated. And some people are more visual. So in the README file, if you are more visual, there's no reason why you can't just put in a description like I have here on the screen. It's easy to read, at least from my perspective, it's easy to read and know exactly what goes in what part of the file name. And a README file, just to summarize, it should include the terminology used for names of files and folders. It should include the structure of the folders, the subfolders in the files. contents of each folder, the contents of each file. And if you're going to change things over time, put it in the README file and date it. Now I'm going to show you a little.
We don't hear any sound on this side. Are we supposed to be hearing it?
Yeah. Don't hear it? Oh, you don't have to hear it because it's, you don't worry, it's just music.
Okay.
Okay. So, and to ensure that you understand what's happening with your research on a daily basis, you should be actually documenting on a daily basis. In other words, the date and the time, environmental conditions. I actually had a research project I was working on, and in the room where I was working, the roof caved in, and it was winter time, so we were at the mercy of whatever weather was outside. And yeah, definitely it changed the values we were collecting. So you need to record the deviations from the procedures, unexpected occurrences, and any thoughts you have about the research. Yeah, you're thinking while you're conducting the research, you're doing a lot of thinking, and if you don't write it down, you're going to forget it. And information from any of the readings or citations. And there's a reason for this, because after you collect the data, basically what we do is we plot the data. That scatter plot on the right-hand side just shows all the data. And you see two little spots that are circled in red. Those are called outliers. And then the list of numbers, you see the $10,000, sorry, you see the 10,000. That's a little bit out of the normal. So an outlier is a data point that differs significantly from other observations. It may be the result of variation in data, or it can be caused by an error in the research process. So this is the reason for that daily documentation. You can go back through the daily documentation and see if anything pops out that might describe why you have those outliers. And I'm going to tell you, since you are working for a researcher who more than likely has a grant, you don't eliminate any data points until you talk to that person and show them where the outliers are. And if you figured out it's part of your procedure, show him or her that, and let them make the decision as to whether to eliminate that data point or not. That's not something for you to do. It's to make the final decision of. It's for your advisor. Okay, now storage. Yes, definitely it's going to be provided by your advisor. But I'm just letting you know, I guess by now you already realize how you're storing your data, but there are electronic laboratory notebooks, or ELNs, on this campus. We have Lab Archives, REDCap, and Jupyter. Lab Archives is an all-purpose data ELN. REDCap is specific for clinical research, and Jupyter is for documenting code. More often than not, you're going to be provided an intranet that's provided by your department or your college. That means the data is going to be backed up and taken care of for you. And the university recently has bought into, well, we've had Viewbox for a while, but we've also bought into G-Cloud and Microsoft OneDrive recently. And all of these are secure environments. We spent an extra, I don't know how much money to make sure that they are FERPA and HIPAA compliant. So they're safe. What you should not be using is Dropbox or Apple iCloud or any of the Microsoft or Google app products that are not provided by the university. Your data really needs to be in a university storage system, so it is secure. Security is a big thing on this campus at this point. And just to clarify, because I know a couple of librarians have gotten to me and said, what the heck are we doing these days? There are 3 different emails to access different software products on this campus now. And if it's a Google product, you use the Google email. If it's a Microsoft, you use the Microsoft email. Everything else, you just use your University of Utah UNID email. And you don't have to use a UNID. You can get that changed so your name shows up instead of your UNID. Okay, so once you completed your research, it has to be archived someplace, and they are subject data repositories out there. I help researchers all over campus find subject repository for their specific research. And librarians put together this registry of research data repositories we call RE3 data. It only has maybe 2,000 listed, and there's a lot more out there. And we're trying to figure out a way to get more and more people to list their repositories in there. So we can start looking for a subject-based repository in RE3 data, but you do have to do a Google search and keep looking and seeking that data. Now there's 2 types of repositories. ICPSR is one type, and nobody calls it Inter-University Consortium, blah, blah, blah. We only call it ICPSR, so just remember ICPSR. This repository has been around since World War II. It is probably the oldest one on the planet. It's social science, obviously, and it connects data with articles. Okay, that's the type of repository it is. Ag Biodata is a genetics data repository for agricultural plants and animals. And this is more or less databases. The data is constantly being updated and constantly added to. It's not linked to articles. They derive some of the data from articles and put it in the database, so everybody can play with this data. There are also institutional repositories, and the University of Utah has an institutional repository. It's called the Hive. You can put your data in here if we don't find a subject repository out there. We've had it for about 4 years now, and I'm one of the people in charge of it. So if you want to know more about it, just let me know. What we're going to be doing in the future, hopefully, is putting together a public interface with a search engine behind it. So all these institutional repositories can be searched from one spot instead of having to go from one institutional repository to another. That takes a bit of time. So how this works is that at the institutional repository, there is metadata and there is DOI. Metadata, that's just a description of the data set. In the library, we have a catalog of books, articles, and whatever. So for the search engine in the library to find the article or the book that you want, we described each one of them. The title of the book, the author, who published it, how many pages, and the different subjects that are under it. So our search engine will go into the list of books we have and find it and bring it back to you. That's the same way this is going to work. The search engine is going to go out, and you're going to put in terminology. The search engine is going to go out and look for data sets that have to do with that terminology, and then it will bring it back to the public interface. And how it brings it back is with that little DOI. It's a DOI is a persistent identifier. A persistent identifier is a little bit of technology and a big book of standards to maintain the persistence. And so the DOI brings the data set to the public interface for you to be able to use. This is something I'm hoping that people will start building. It isn't happening at this point, but I do know that the Department of Energy has put together Data Explorer. That's that URL down in the right-hand corner. They've already had this in existence for about 5 years now, and so they list out to all of their data sets. You can go play with it and see how it works. And for your future, you're going to eventually graduate from college and look for a job or apply to graduate school or a professional school, and you will need a resume. So for this project, you are going to put together a poster, and that poster can be submitted to USpace. That is our other repository. And once it's in USpace, it is considered published. USpace will give you a persistent identifier. So what you do is you put together a citation, add the persistent identifier, add it to your resume or your CV. So those people who are interviewing you, they will know what great work you did at the University of Utah. And it's not only this poster, it's any poster you develop on campus for a research project, you can put in here. So are there any questions?